Hi everyone. Now we have to learn how to differentiate natural exponential and natural logarithmic function. Okay, from the slide you can see that if I have an exponential function with a power of fx, in order to find the derivative dy dx, we have to consider this as our inner function. All right, fx as our inner function. We differentiate fx, we put it here in front, and then later we copy this whole thing here. All right, so dy dx is the differentiation of the power, put it in front, and then later you copy this whole thing again. All right, this is how to differentiate a natural exponential function. All right, if you have a natural log function, so ln fx, in order to find the derivative, you have to consider this as your inner function. You differentiate this, put on top, this your f prime will be your numerator, and then you copy your fx here. All right, so if you apply these rules correctly, you can solve this problem. Okay, so why not we solve the problem together, right? So a y equals e3x plus 2. Now what is our fx? Our fx is this one, right? So we differentiate 3x plus 2. What do we get? We got 3. And the 3, this 3 must be put in front. And then these e 3x plus 2. E 3x plus 2 has to be copy and paste at the back of the 3. So your answer dy dx, the dy dx should be equal to 3, right? Differentiate the power, you get 3, and then later you copy e 3x plus 2 again. So this is the final answer. Next, if you want to differentiate natural log, ln 3x minus 5, how to differentiate this one? Okay, so we need to again identify the inner function. The inner function is 3x minus 5. Differentiate 3x minus 5, you got 3. And then later you copy 3x minus 5 and put it at the denominator. As a result, my dy dx equals 3 over 3x minus 5. This is my final answer. Okay, if you do not have any question, let's continue with question 1. Differentiate the following. All right, so question A. Again, I want to differentiate natural exponential function. This is my power, this is my fx, so I need to differentiate this one and put it in front. So differentiate x squared plus 3, I got, okay, first of all, I must write dy dx, right? So later I get 2x plus 3x, okay? 2x plus, no, 2x plus 3, sorry, 2x plus 3, okay. And then later we multiply with e x squared plus 3x. Okay, so this is our final answer for question 1a. Question b, this is our inner function, right? So we differentiate this, put it on top, and then later we copy this one and put it at the denominator, put it at the bottom. So my dy dx, very quickly, I get 2x minus 1, right, over x squared minus x minus 6. So this is the final answer for B. Okay, if you do not have any question, let's proceed with slightly challenging question. Question A, you have y equals x power 4 e to x. All right, this is not easy because I have a polynomial, x with power 4 multiplied with natural exponential function. So in this case, I must apply product rule in order to find dy dx because I have a function multiply with another function. So I must apply product rule this time. So what is my u? Of course, it is x power 4. And what's my v? E 2x. So my dy dx is equal to v du dx for x cubed, right? My du dx is 4x cubed plus u dv dx 2e2x. Okay, simplify all this. I will get 4x cubed e2x plus 2x power 4 e2x. Can you see that? Can you see that? I have e2x for the first term on the first term, and I have also got e2x on the second term. So I can factorize out e2x, right? Here I got x cubed, here I got x power 4, which means I can factorize x cubed as well, right? So this term I got 4 and this term I got 2. So the factor of 4 and 2 is 2. So I can factor out 2 as well. So my final answer and the simplest form for this is 2x cubed e2x bracket 2 plus x. That's all. Okay? If you do not have any question, then we can proceed with question B. So question B says you have y equal to x ln x squared. Okay, so this is my u, and this whole thing is my v, right? So similarly, I must apply product rule in order to find the dy dx because I have something multiplied with something. A function x, a linear function, multiplied with a natural ln, okay, natural logarithmic function. So my dy dx equal to v du dx, which is 1, right, plus u dv dx. So I got 2x over x squared, right? Differentiate logarithmic function. So we differentiate x squared, put it on top, and then x squared we copy down, right? So simplify everything. I get ln x squared plus, this one I can cancel, right? And then this x I also can cancel, so plus 2. So this is my final answer. Okay, so let's proceed with the last question, one last question. Okay, because we have question A, B, and C, so maybe we try question B and C together. Question A, you can do that at home or during your free time. Okay, so let's get started. Question B, I have y equal to x minus 1 e power 3x. So by right, you should already know I must apply product rule to differentiate this function, right? Because I see a function multiply with another function. I must apply product rule. And this is my u, this is my v. So very quickly, if you have already familiar with the product rule, I no need to write down u, write down v, later write down u prime, write down v prime. We can straight away apply them into the product rule. So v du dx, you get 1, right? You differentiate this one, you get 1, right? And then plus u dv dx. dv dx, you got 3e 3x. So as you can see, the first term I have e3x. The second term also I have e3x. So I can factorize out e3x together. So I will factorize out e3x. So the first term left with 1. And then the second term left with 3x minus 1. Right? And then let's continue our simplification. So we have 1 plus 3x minus 3. And then our final answer is 3x minus 2. Okay? Question C. Question C, we have y equals 2x cubed minus 5x to the power of 1 over 3. So guys, in your opinion, should we apply product rule or quotient rule in order to find the dy dx? The answer is no. We must apply the chain rule because we have something to the power of something, right? So chain rule says the power bring to the front, power minus 1, then later we differentiate the inner function, right? Okay, so let's find the derivative of y. So here we have 1 over 3, 2x cubed minus 5x. 1 over 3 minus 1, we got negative 2 over 3, right? And then now it is time for us to differentiate the inner function. Our inner function. Differentiate this, we got 6x squared minus 5, right? So we got 6x squared minus 5. So if you want to simplify our answer, we get 2x squared minus 5 over 3, 2x cubed minus 5x to the power of negative 2 over 3. How do I get this one? Because I'm multiplying 1 over 3 to this function. So 3 and 6 can be cancelled. So I got 2, and 3 and 5, I got 5 over 3. Okay, so there's one more question. Okay, there's one more question. I hope you can try this during your free time. And if you have any question, you have any doubt, please do not hesitate to talk to any of the mathematics lecturer. All right, have fun learning. Bye bye.